Welcome everyone to this lecture on the topic of fluid mechanics. So let's begin. I hope it is visible, pretty light. So fluid mechanics, we basically study the idea that how a fluid behaves in nature. What is a fluid? If we were to ask how would we identify a fluid? So we think that uh, its density is something which is pretty important to us. We typically see that bodies having higher densities. They basically are floating at the bottom of uh, water. If we combine that particular fluid with water, then it would basically sink in the bottom. And if we take a lighter fluid and then we combine it with water, then it would float at the top of water surface. So that's the one way which we use to define uh, whether a fluid is lighter or heavier than water. So density is something which is pretty important, right? For example, if I were to think, okay, what are the common fluids around? So one of the common fluids around you is milk. Like we all will mostly drink milk in the morning. So it's heated uh, for some reason, and then when we drink it, uh, so we say that its density is somewhat matching that of water. Because of that, it is able to form some kind of emulsion or suspension in it. So these are very important things. So let's define what the density is. So here I have written density. Density, it is the symbol of density is rho. Uh, the formula for density is mass of the body or mass of the fluid divided by volume. Mass is 1 kg and volume is equal to 1 meter cube. So density is defined as 1 kg divided by 1 meter cube. Or if I want to define what is the unit of density, it's 1 kg upon 1 meter cube. So let's say we have some kind of oil. So oil we have, let's say mass of that particular uh, substance which we have taken is 700 grams, and it's contained by a beaker whose volume is 1000 centimeter cube. So what is its density? So its density is going to be density of that particular fluid whose mass is 700 and volume is 1000 centimeter cube is 700 divided by 1000 gram per centimeter cube. That would be some 0.7 gram per centimeter cube. So that is what density is. And different fluids have different density. For example, if I were to ask you what is the density of mercury, you would say that yes, we know its density, its value is some 13.6 times that of density of water. So I'll tell you what is the density of water. Density of water is 1000 kg per meter cube. So that's the density of water. Uh, but how does it help us in basically writing the density of that new fluid? Right, that is mercury. So mercury's density, we can remember, is 13.6 times that of water. So it's a pretty nifty number. We don't have to remember this pretty big number and the simple value called 13.6. And value of density of water is 1000 kg per meter. So density is pretty important thing. Like we say honey. The honey is pretty dense fluid. If we mix honey and water, uh, we see that the honey basically tries to settle down in that particular watery drink. And other examples we can take. For example, we are taking some kind of uh, let's say oil we have. There is an oil deposit inside on the ocean floor, and you are a petroleum engineer. You have to basically extract oil. So it's pretty common sense to think that whatever oil uh, molecules are present inside the oil bed or in the sea bed, the lighter molecules would be relatively situated upwards, and the denser molecules of the carbon, hydrocarbon, they would be situated closer uh, to the at the bottom of the seabed. So this is how we can think simply that how density affects how substances interact with each other. And if we want to extract that oil out of that particular seabed, then what kind of machinery would we require? What basically, what pressure would we require so that it is able to pull that oil outside of the bed? So initially, when the density of the hydrocarbons is less, it would require less pressure difference. But when the density of hydrocarbons keep on increasing, as it is getting emptied out, you would require more and more pressure to basically extract that particular oil. So you as an engineer can take a decision that if we can supply more fuel inside that particular oil bed, which we can distill out later, but uh, decrease the density of the overall oil present inside that particular bed. So with that, we define the term called relative density. So relative density is defined as density of the fluid divided by density of water at triple point. So if this is not visible, then I'll basically repeat the statement. It is density of the fluid divided by density of water at triple point. This is defined as the relative density of the substance. For example, for mercury, its value would be density of mercury divided by density of water. This value would be some 13.6. So it's pretty convenient value. Next, we want to define something called pressure. So what is pressure? Pressure is something which acts on some particular surface when we apply some kind of force on it. So that means that we basically need to first visualize some kind of surface. It could be some solid surface or it could be some imaginary surface. For imaginary surface, we need two forces acting on that particular imaginary surface so that they basically cancel out. And we can say that the force divided by the area is called the pressure acting on that particular surface. Because we usually link pressure with some kind of physical thing, some physical perceptible thing, the forces which are basically measurable by us. But pressure is simply defined as some kind of force acting on an area. or force per unit area. So it does not necessarily mean that that force does something or it moves something. It should simply act. So in the same way, we just need a surface. Let's say that surface is drawn like this, the square surface. And in this square surface, I have some kind of F force acting like this at an angle theta, like this, right? So this force F, which is acting at an angle theta, we say that the force F will produce a component or will have a component which is perpendicular to this surface. So this is like a square surface. On this square surface, the force is acting at an angle. So we say the perpendicular component is F cos theta. It is F cos theta because we can take two components like this. And a component of force which is attached to angle theta is a cos component. So we say that the pressure acting on this surface, let's say A, is the perpendicular component of the force, that is F cos theta, divided by the area of the surface. So this is what pressure is. If this is an imaginary surface, some kind of, or any kind of surface you imagine, we can take that the surface is at rest and this force F is acting like this. Even if it not as rest, whatever force F it is there, it will basically exert some kind of pressure. So this is F cos theta upon A. This is pressure P. We say that the value of pressure P, its unit, is 1 Pascal. And it is also has a unit of 1 Newton per meter square. So let us take an example. Uh, for example, let's say we have some kind of table, and on that table we have kept, uh, let's say, a lot of bottles, and one by one we are increasing the number of bottles kept on the table. So, what do you think will the force uh, transmitting through the its legs affected? How will the transmitted forces get affected? Definitely, the forces will increase as we are increasing the number of bottles on the table. The force on all the four legs increases. Some leg may experience more force, some leg may experience less force. So for the sake of that, we let's say okay, all the bottles are placed in a uniform manner. Okay, so let's say you are fond of drinking whatever you are fond of drinking. Let's say water. You want to feel hydrated. Okay, and so you are drinking lots of water nowadays. Exactly, you are encouraging your friends as well drink water. Okay, because it's the healthiest drink. It is so. If let's say you took a challenge, okay, I want to pee a lot tomorrow, and let's say drink 10 bottles of water, which you shouldn't do. But if there is a table like that, and you basically distributed 10 bottles of water like this, and each leg has some cross section. Now, what do you mean by cross section? Cross section means that what is the area of that particular leg if we basically cut it transversely. Transverse means that it's perpendicular. So area of each leg, let's say area of each leg, A, that is area of each leg, that is 10 centimeter square. Let's say very thin leg. Okay. So when you put the water bottles on top of this particular table, what will happen? Area, the force in each leg will increase. Okay. And let's say you have basically filled all those water bottles with uh, water, and then each water bottle weighs some 1 kg, right? So this you can imagine, right? So every 1 liter water bottle roughly contains 1 kg of water, right? Like that, approximately that's the density of water. And we will talk about milk. Let's say if you want to drink, you become MS Dhoni, है So you would basically say that this value would be somewhat 1 kg, 0.98 kg, somewhat like that. Density of water is also close, density of milk is also that of close of water. So density of milk is somewhere like 0.980 kg gram per centimeter. But for now, we are taking water only, right? So we'll say 1 kg of water is being filled in each of the water bottle, and we are basically filling it like that. So after that, we basically say that now the water bottle is like this, and that particular water bottle is uh, basically placed on the table everywhere. So these are 10 water bottles which are placed like this, and they have basically they are exerting force on the four legs of the table. So how do you find pressure? Pressure. How will you find pressure? Pressure we'll find using 10 kg, because that is the total weight acting on the table. So 10 kg will convert into force. So 10 kg mass into action of gravity, that is 9.8 meter per second square, divided by the area of the four forces, 4 into the area of each leg, that is 10 centimeter square. Centimeter square means that it is 10 to the power minus 4 meter square. So 1 centimeter is 10 to the power minus 2. Square means 10 to the power minus 4. So this value will become some 98 divided by 40 into 10 to the power 4 Pascal. So this value will be P is equal to 98 upon 40. So 98 upon 40, this value would come out to be some 49 upon 20, or this value would be some 24.5 or 2.45. So this is some 2.45 uh, into 10 to the power 4 Pascal. So this is net pressure acting on each of the legs. So this is what pressure is. So in the next lecture, we will learn about absolute pressure. We will see that what is the effect of atmosphere when we consider its values, air particles, and then a question for you or home would be: let's say if all these water bottles uh, you have basically empty and replace it with the fluid mercury. So when you fill all the bottles with mercury fluid, then what would be the effect of the pressure acting on each leg of the table? So thank you.